In this tutorial, we will cover plotting approaches in EES. We'll talk about property plots, which is a family of plots that are extremely useful, and again is due to the fact that we have all these properties built into EES. And in order to make the connection in the student's mind most logically, I'd like to use the example in Excel. If I ask you to create a plot, you first need to create the column of X, the column of Y, and then you select those two columns and you plot them in whatever form of plot you've been asked to plot in. So that's kind of the general approach that one will take in EES as well. You just have to generate that table on the side. But in order to generate that table, we first got to create some equations. So for this example, what we're going to do is we're going to assume we have a liquid nitrogen dewar, DEWAR. This is the container that I would carry around the liquid nitrogen in. And if I'm almost empty and I go back and I get it refilled, we want to know some of the properties of that tank after it's refilled, depending on how much mass of nitrogen was input into the tank. So let's start by creating a variable, and if I wanted to use nitrogen multiple locations as I look up different variables or different thermophysical properties, then this is how I create that variable nitrogen, and I can just come down here, and if I wanted to evaluate that, I just need to type that F and $sign. So let's assume we've got a fixed volume. The volume of my tank is maybe 10 liters, so let's convert that to meters cubed. We'll work in fundamental SI units, and this is not pressurized. Right? So those liquid nitrogen dewars are at atmospheric pressure. So for my pressure, I'm going to just round that to 100 kPa, just to make my life a little bit easier from a round number perspective. And if I take this 10 liters and I get it refilled, they're going to typically tell me the weight of the liquid nitrogen, and they'll charge me according to that. So let's say that the mass here is 11 or 12 pounds. So I'll convert that from pounds mass to kilograms. And because I know my mass and I know the volume's not going to change, and that mass is, after I fill it in, what it is, assuming I'm not losing any mass. There's going to be small leaks, but because mass is fixed and volume is fixed, then the ratio of those two, mass divided by volume, is also fixed. Therefore, my specific volume is a fixed number, and that'll just be my volume divided by the mass. So let's go this far and make sure we get rid of all of our unit issues. And the reason for this one is because I haven't given this guy any units, so that'll be meters cubed per kilogram, and my unit problems go away. So one thing I want to highlight here, we're going to eventually create a table, but then we'll create a plot. But there's another plot up here that's always available to you even before you write any code in the equations window, and that's this property plot. And if you click on that, then you can select different types of fluids, whether it's ideal gas, a real fluid, or brine. We're going to use real fluid, and I'm going to go to nitrogen because that's the one we're dealing with. And I'm going to do a property plot. I'm going to plot temperature on the x-axis and specific volume on the y-axis, or temperature on the y-axis and specific volume on the x-axis. And the default here is to include a bunch of extra lines that are just going to muddy up the figure, especially since we don't have any reference in what they mean. So I'm going to get rid of all these, but I do want to come back and include one pressure line at 100 kPa. Why? Because that's the pressure that I'm operating at here. And so this is going to show a line of constant pressure once I click OK. And so you see I've got nitrogen. Here's my specific volume. It's important to note this is a log scale here. And this is what a constant pressure line would look like. It's going through the vapor dome at a constant temperature, and then once we get to a saturated vapor condition, then we start to increase temperature quite rapidly. But if you're familiar with liquid nitrogen, you know it's about 77 degrees Kelvin that this exists at on a tabletop, on a non-pressurized, on an atmospheric pressure environment. And so this is the line that we're going to be operating under. And so if I now have two state variables. I know pressure and I know specific volume. And so with everything else, I can just simply look it up. So I could assume that I'm in the vapor dome, and I'd be surprised if I'm not. I can assume that, or I can just rely on the fact that my specific volume is known and my pressure is known, therefore I can determine anything else. And so I just use the temperature function, and for that first input I just type my variable that I defined as nitrogen. And I need two more, so that would be pressure. And again, it doesn't matter the order I put these in. I could have put specific volume first. And here's my temperature in Kelvin. And if you're getting an error still at this point, then you might need to go into your preferences here and make sure that Kelvin is selected and not Celsius. So my temperature is at 77.24 Kelvin, and if you look that up in property tables for nitrogen, you'll see that is the saturation temperature if my pressure is 100 kPa. And so what else do I care about? Let's say that I cared about the quality. Quality is another state variable, another thermophysical property that I can just look up. And so I do the same thing here. And this is unitless. So you can see my quality is 0.0035, which means that less than 0.4% of the mass is in vapor form. So the vast majority, 99.6 or so % of my mass is in liquid form. And that's really what you want when you go and get the dewar filled up at the liquid nitrogen store. So let's create some plots out of this. This here is meant to help us visualize. I wanted to show you the option that you have in here to generate these plots, but this also helps us visualize what's going on from a physics standpoint. So I've got a specific volume of 0.002, and so here is 0.1, 0.01, 0.001. So I'm right at this point here. That's where my physical point would exist, and I could actually come in and create a point. We're not going to do that just now, but what we're going to do is we're going to explore the possibility of going and getting this refilled, and a different amount of mass has been inserted, it has been deposited into the dewar, and I want to see the dependence that quality has on how much mass was input. And so how I do that, I've already got mass in here, I've already got quality in here. What I do is I create a parametric table. So this is like the Excel spreadsheet. I need to create my columns, my X and my Y. I can come here, or I can come in plots and do, or tables, I'm sorry, new parametric table. Either way, it's going to give me this option, this dialog box here. And here is where I decide the variables that exist that I have created in my work, in my environment here, are contained in this left window, and I just need to decide which ones I need to move to the right window. And the answer to that is, well, which one do I want to change, and which one do I want to see how it responds to that change? And the answer to that is mass. I just said I'm going to change the mass, and then I want to see what happens to quality. And the default here is to have 10 rows. I can go after the fact and increase that. Let's leave it at 10 for now. And so I'm left with this table that is 10 rows. If I increase this there. So 10 rows, and it's completely blank. And so I can switch the order of these if I want to. I want mass just because I'm used to seeing X column and then a Y column. But here's where I'm going to right click and just say I'm going to alter these values, and I'm going to start at, well, let's get an idea of what the kilograms is first. Let's cancel that, run this again, and so this mass is, so I want to go from, that's 5 kilograms, maybe I want to go up to 12 pounds, so 5.5 let's say, and then let's go down to like 2 pounds. So let's go from about 1 to 5.5. That should cover our range. And so I come back to my table and I right click here and I go from actually let's do 0.5 to 5.5. And so it creates this evenly spaced vector of those masses. And what I want to do is either I could push this play button here, which solves the table, which considers mass at each of those individual numbers and then solves for x, or I can come up here to the calculator with the table in front of it. That's the same operation, but either way it's going to create an error, and the reason why is because in this table I'm trying to say that mass takes on 10 different numbers, but over here in the equations window I'm giving mass a single number. And so all I have to do is come over here and comment that out. And now when I come in here to solve the table, it does so for me. And so at a mass of a half a kilogram, I'm at 8% quality, 8.6%, and that goes down the more mass I add. And so now I can come, now that I have my table created, I've got my x column, my y column, I can come up here to a new plot window, or I can come up in here and do the same thing. And then this dialog box, here's where I decide what's on the x. I want mass and I want x on the y-axis. I want to see the response of my quality as I change the amount of mass that I put into this volume. And EES does a fairly decent job of just automating your min and max and intervals here, but if you need to change these, you can do it after the fact too. If you want grid lines, you can have grid lines. If you want a log scale, that option's there for you. And if you have an array and you say, well, I don't want to plot all 10 rows, I just want to plot 9, and so I could change that input here. I could select this box, which means if I change pressure, for instance, I want to look at 200 kPa instead of 100 kPa. I'm filling this dewar in a pressurized fashion somehow. Then the graph is just going to automatically update. As soon as I change anything to update that table, that graph is going to update automatically. I find it more useful to give a plot based on the data and then change this, tweak the pressure or whatever, and then run it again and then have that same item on the plot. But that's there for your reference. This is one of my main problems with EES, my main issues that I wish they'd change. To my knowledge, at least, there's no way after you create the plot, if you forget to add a legend, I have not found a way to go and add it after the fact. And so if you need a legend, if you're putting multiple plots, multiple curves on the same figure, then you'll need to have some sort of legend to help the reader understand which is which and so forth. So I can come in here, I want to add a legend. I could add point labels if I want to. I'm going to add some points along with the line. Let's just take a look at that. And so this is here's my legend, and I can click that and I can move it around a bit. I could change the min and max of either the y or x axis, but this is what it looks like. And so if I add more and more mass, and we saw that from the table, that the quality of all of that is changing. And the reason why is because if I put a certain amount of mass in there, it has its own density that the liquid state does. And so if I fill only part of that 10 liters, then the rest of it's available for vapor. And so because this is not pressurized, it's going to generate a little bit of vapor and fill that extra volume with the vapor. And so the less amount that I fill it, the more empty space I have for that vapor. And so it makes sense that the more mass I put in, the smaller amount of leftover room I have, and so that's going to be a lower quality, less of my volume is available for a vapor. So maybe I don't like how many points are here, so I can come back to my table and I say I want to insert some runs. Let's insert another 10 runs. And I'm going to have to redo this part here, and I want to use that same window, hit the execute button and come over here and either create a new plot or get rid of this plot. or I could put it over the top of that. I'm just going to create a new plot here, add the legend item, get my symbol back on there. So that looks like a smooth curve to me now, at least smoother than it was here. So I'm going to take this plot too, I'm going to delete that, and if I right click here I can name this something else. I can put a description down here, and so when I print, it prints that description for me. But let's see what happens now if I change the pressure to 200 kPa. I can come in here and I can re-execute this. I get different numbers here for that, and I can come to this same plot and I do what's called an overlay plot, and I want to plot the same things. I want to make sure I include a legend item for that. Makes the color, I got different symbol, that's all good. And so here I can double click this now and just rename that. So this was P equals to 100 kPa, and the second one was, and I can move this over a bit, and this one was P equals 200 kPa. And so if I were to pressurize this, I get different performance, different quality results from that. In either case, as I go towards more and more mass, I'm going to reach a point where I have too much mass for that pressure and I've filled the whole volume. And once that happens, for instance, if I come here and I say, and maybe the company said, look, we put 15, let's take this back to 100 kPa, we put 15 pounds of liquid nitrogen in there. Well, that's actually still reasonable, and so my quality is greater than 0. But if I get up to say 20 pounds for that volume, then I get this error that gives me the temperatures out of the range. If I decrease this, let's find something that still lets me calculate, but gives me something that shows me that they lied to me. There you go. So in this case, my quality comes back as negative 100, which means I've filled the tank and then more. There's no room left for any kind of vapor. And so if they come back and tell me, look, in your 10 liters we put in 18 pounds, I basically know that there wasn't room enough to put 18 pounds in there. So, but hopefully that gives you a brief overview of the plots. And when I come here to print the PDF, I've got my plots there, and make sure that's checked. And so here's my, let me change this here. My results are my solutions window, or my equations window, first of all, my solutions window, and then it includes that parametric table that I created. I can deselect that if I want to. And then it creates the plots that I had. So I had 2 plots on this in this EES script. I had the TV diagram for nitrogen, and then I have this plot that I made here with the legend and labels and everything. So, okay, thank you, and this concludes this tutorial.